Hey, hello students. In this video, we are going to discuss about one important reaction which is called Clemmensen reduction. So this reaction is very useful for your IIT JEE, NEET and also for your board examination. So let us start the video without any late. So exactly what happens when aldehyde or any other ketone, when aldehyde or ketone or collectively we can say one carbonyl compound, when it undergoes with zinc amalgam with HCl, which is called acid, then it forms the corresponding product which is called alkane, and this reduction is called what? Clemmensen reduction. So if we take an example, for example we have to take CH3 CHO. Now this is called acetaldehyde. When we take acetaldehyde, so it will form, when it reacts with zinc amalgam in the presence of H plus, or we can say acid, then it forms the corresponding product which is C2H6. Now this is called ethane, right? So this is the thing we get over here. Now if we take any other ketone, for example if I take acetone, CH3 C double bond O, and here it is CH3. Now in the presence of this zinc amalgam with H plus, it forms the corresponding product which is obviously CH3, CH2 and CH3. Now this is called propane. Now this is called propane, right? So this is the thing of Clemmensen, but this is not like that. We have to go through different questions so that we can understand exactly what is the kind of reaction is this. So let us do some questions on it, right? So when it goes with zinc amalgam and HCl, it will obviously form one alkane product like this. So simple to form the product, because here we have to just remove the double bond O. For that double bond O, 2 bonds are there for oxygen, so we have to put only 2 bonds for individual hydrogens. That's it. So we don't show the hydrogen. That's why we can directly write in this way, which is called like this. Now this is called cyclopentane. When we go to the next question, obviously now you're so smart, we have already got the answer, right? So this is cyclohexane. This is called cyclohexane. Now in this particular question, obviously what is there? This is CHO is there, obviously acetal kind of aldehyde group or aldehyde functional group. Obviously this will convert into alkane type. So here we can say that here one carbon is there, one carbon and one carbon is there, so obviously it will form into corresponding alkane type product, right? So if I want to show in this way, then we can also do in this way, like this can be written as like this: C double bond O, here it is H. I have just expanded it. So what we have to do actually, so we have to break the 2 bonds for double bond O, and we have to give 2 hydrogens for that. So 2 hydrogens for this, and here 1 hydrogen is there, total 3 hydrogens. So we can write here exactly as CH3. So same goes for this CH3 and same goes for this, which is CH3. Now this is called mesitylene. What is this called? This is called mesitylene. So this is the kind of product we will be getting from here. Now when we go to the fourth one, we can see here there are 2 carbonyl groups are there. Carbonyl groups are there. This is very interesting question. The kind of product we'll be getting as, if you think like it will come like this, it is completely incorrect. Why? Because I want to highlight this one. Here what we have, sir, we have 2 double bond. So I mean carbonyl group is there, and this one is inside the 2 bulkier groups. 2 bulkier groups. That's why this particular organic reaction will not be occurred in this particular position. That's why only this carbonyl group will be reduced to alkane, but not this one. So we have to write in this way, that is in this way, so that now it is absolutely correct. That means from here we got the another point, that this Clemmensen reduction, Clemmensen reduction is a crowding effect. We can write crowding dependent effect or dependent reduction reaction. So we got the point over here. It's very important to understand that because of the crowding, it is not going to react on that carbonyl. Okay, and we got the particular product like this. So now we have to go the fifth one, okay, where we can say this is also very interesting question and important as well. Okay, this one is also important. So let us look at here. So here we have, okay, here we have carbonyl group and here we have OH, right? So here, if we expect that, if we write in this way, right, let us write this one as well. Okay, so in this OH, now it is completely incorrect. Okay, how? Because here we have the OH group and here we have H plus. So H plus and OH, obviously they will attack. Okay, they will react, right? So the corresponding product will come out as, okay, let me erase this part. Okay, let me erase this part. And now what will happen? This OH, okay, once again, so let me erase this part as well. So I'll write again, okay, to understand more clearly. OH, now we have the two lone pairs on the oxygen. So what will happen? So it will react, okay, take up the H plus and will convert OH2 and plus. Now this one is a good leaving group, right? And we will get in this way, okay, right? And here it is H2 will be removed, and here we will get the carbocation. Now what will happen? Obviously H plus means kind of HCl, right? So Cl group will come out, Cl minus, and that will come out as and will attack on this. So right there, like that. So this is the corresponding product we will be getting from this particular thing. So we have to take care of the OH group as well, because that will be converting into Cl. Okay, that will be removed by, or that will be replaced by Cl group. Okay, because H plus means HCl, right? So we should not worry about it. Okay, so let us go to the next one. It is also very like mixer question. Okay, all the groups are there in a one compound, so we can write this as well. So what is the expected product? Please pause this video and please write down by your own so that we can understand very clearly, right? Okay, right, let us write this. So here we go, right? Double bond O is there, this one double bond O, so no need to write anything because the hydrogen we generally don't show this one. And here it is COCH3. Now this will convert into a ethyl group, right? I can write in this way, which is called ethyl group. And now it is CHO group, so obviously it will convert into CH3 methyl group. Okay, now yes, now this is OH, so this will be replaced by chlorine group, and here, or as usual, it is a methyl group. So this is the corresponding product. I hope now you are clear with this. Okay, now seventh one. Oh my god, seventh one is very important and interesting question as well. Let us do that. Okay, it will be funnier. Okay, example. So right, so we have this one. Okay, obviously this will be converting to ethyl group because CH2 CH3. If somebody is not getting it, then I can also write in this way, right? C for 2 oxygens, so I have to write 2 hydrogens, CH2, and already CH3 group is there. Now this is called ethyl group, right? Right. Now here what will happen? So here we have the lone pair, right? Oxygen will have the lone pair. Obviously it is going to react with H plus. So what will happen? Okay, here O, okay, is making bond with H, and here also O is making bond with H. Now obviously there is a bond, okay, already there. So an oxygen is now having what? How many bonds? 3 bonds. So 3 bonds is not stable at all. So it will be getting one positive charge. Now what will happen? Bond fusion will act. Okay, bond fusion will act. Okay, so this bond will be coming like this, and this bond will be coming like this. So now what will happen? Okay, it will be converting into like this. Okay, one second. Yeah, so this is the thing. Okay, here ethyl group is there, and here it is OH, and here it is OH. Now the byproduct is obviously this one. Okay, here Cl, and here Cl will come out, right? I hope it is clear right now. And now on one carbon, 2 hydroxyl groups are not stable at all. That's why, okay, that's why what will happen? That's why water will be removed. Okay, water will be removed, right? And we will be getting like this. Okay, ethyl group, and here it is double bond O. Now Clemmensen reaction will happen on it, and then the final product will be like this, ethyl product. So now this is called ethyl cyclohexane. Okay, so this is a very interesting question. Okay, Clemmensen reaction happened, okay, reduction happened, so the double bond O will be reduced to alkane group. So this is the final product. Okay, let me highlight this one. Okay, this is very interesting question. Okay, right, so this is a thing. So I hope it is clear right now. And the last question we have, which is called 8th one. Okay, in the 8th one, okay, if we expect, okay, we get this product, okay, then it is completely incorrect. Okay, this is completely incorrect, right? So we this is called 1,3-diketone, and in this 1,3-diketone, it's a very, very important expected question. 1,3-diketone will not convert into 1, 2, 3, 4, 5, just N-pentane. N-pentane is not the right product for it. Okay, so if you want to write this answer, or if you want to get this answer, then we have to go through the mechanism. So without any delay, let's go to the mechanism part of the Clemmensen reduction. So let us go for the mechanism part of this. Okay, so here we will take one aldehyde or ketone, whatever we want. Okay, let us take, okay, R1 C double bond O. Here it is R2. Now this is called a ketone group. Okay, so in this ketone group, obviously what will happen here? So so we have taken the metal work or metal function is just to oxidize. Zinc will be oxidized into zinc 2 plus and will be liberating 2 electrons. Now this 2 electrons character is very, very important right now. So what will happen at the first case? Okay, at the first case, this will be undergoing homolytic fission. Okay, if we take the homolytic fission, obviously here one radical and here one radical will be developed. Okay, this is common. Now what will happen? So 2 electrons will be released. Okay, sorry, 2 electrons will be reacted to this particular carbon and oxygen. So we will be getting like this R C. Here it is O minus charge, and here it is minus charge, and here it is R2. So this is a thing, this is a scenario we get over here. Now what will happen? Okay, we have taken HCl, so H plus will be there, right? So 2H plus will come out. Okay, so it will react like this and it will react like this. So then we will be getting like this RCH, here it is R2, and here it is OH, right? After getting this, okay, after getting this, what will happen? So 1H plus will be again reacting with, okay, oxygen. Okay, because oxygen is having what, lone pair, H plus is there, so reaction will be happening. So what will happen here? So now we will be getting RCH, and here it is OH2. Obviously positive will come out here, and R2. Now we know that H2O is a very good leaving group, so H2O will leave, and then we will get RCH and R2. Now carbocation will be formed. After forming the carbocation, what will happen here? Okay, what will happen? Right, so we will be getting this product like this RC, okay, H, okay, here it is minus charge, and here it is R2. Now at the end, so HCl is there, so H plus will come out. Okay, it will react with H plus, so at the end we will be getting RCH2R2. Now this is the final product of this particular reaction. So here obviously H plus addition is occurring. That's why this reaction is called what? This reaction is called reduction reaction. This is called a reduction reaction. This is the reason, right? This is called reduction reaction. Okay, and how many moles of electrons are used? Obviously, if somebody will ask you how many moles of electrons are used, here 2 electrons. Okay, and another case, obviously here 2 electrons here. So total 4 electrons are used, okay, in this reaction. So this is the case we have to go through, right? So this is the mechanism part. I hope this mechanism part is also clear with you all. Okay, right? Now let us go to the next part, which is called, okay, eighth one, number 1, which is having 1,3-diketone. So let us do this question again. Okay, yes guys, now it is clear that, okay, now it is clear that we have to go through the yes guys, now it is clear that this mechanism part is now clear. Now we have to go to the main question, which is there, 8th one, okay, 1,3-diketone. So let us do that. Okay, it is very, very interesting question. So here it is. Okay, this is 1,3-diketone, right? And when it reacts with, okay, obviously 2 electrons, because zinc is now converted into zinc 2 plus and 2 electrons. So what will happen? Obviously we can write directly. Now you are so acquainted with the mechanism part, I hope. So the coming reaction is like this, double bond O, here it is minus charge, and O minus will be here. Now what will happen? Okay, what will happen? So this is going to, okay, react with this carbon and it will come like this, and it will form a ring like structure like this. So let us give the numbering also. Okay, here it is 1, here it is 2, and here it is 3, right? So the coloring, the numbering has happened. So 1 2 3, so it will come like this, a ring like structure. This is 1, this is 2, and this is 3. So the bonds are like this. At the 1 bond, okay, O minus is there, and at the, obviously methyl group is also there. At the third position, okay, we will write in this way. So here it is O minus, okay, and here it is one methyl group is also there. So what will happen here actually, okay, so this bond will be coming like this, and this bond will be breaking like this. So now what we'll get over here, okay, so here it is, right, double bond O, here it is methyl group, and here it is a bond, and here it is O minus, and here it is, okay, like this, okay, and here CH2 minus group is there, right? Here it is thing. Now what will happen here actually, okay, so so 2H plus will come out here, and we will be getting like this double bond O. Here it is methyl group, and here it is going like this, and here it is OH, and here it is methyl group, and here another methyl group has come out, right? So after getting this, okay, after getting this, we will be going like this. Right guys, so here what will happen, so here H plus is there, so this OH will react on this H plus, then we will get like this double bond O. Here it is methyl group, here it is there OH2, and plus charge will come out here, and methyl group, and here it is another methyl group is also there. So what will happen here, now H2 will be removed, okay, H2 will be removed, and carbocation will be formed, right? So here it is, one second, here it is like this, two methyl groups are there, and here it is carbocation group, and here it is double bond O, here it is another methyl group is there, right? So now after adding with 2 electrons, because 2 electrons is also there, okay, 2 electrons, so the carbocation will be neutralized like this, okay, one second, yeah, so this is neutralized, and here double bond O is there. At the end, okay, at the end, obviously it's a carbonyl group, so what will happen, so Clemmensen reduction will occur on this particular carbonyl group. So at the end we will get the corresponding product like this, okay. So this is the final product, and the name of this compound is obviously 1, okay, 2, and this is 3, and this is 4. This is called 2-methyl, okay, butane. 2-methyl butane is formed, okay, 2-methyl butane is formed. So this is the corresponding unexpected product has been formed from this Clemmensen reaction, and this one is very, very important, okay. Okay, right, sir. So this is the thing. I hope this video is helpful for you guys. Okay, you got to know many points from here. If you really like this video, then please like, share, and subscribe my new channel. It will be very, very helpful for me. Thank you so much. We'll meet in the next video with a new name reaction.